We will now do one example where Turing machine acts as a language acceptor. Okay, so language acceptor. Although this problem previously we have done with push down automata, but we will done this problem with Turing machine also. So since push down automata can resolve this problem, obviously since the Turing machine is more powerful than push down automata, so Turing machine can also resolve this problem, but we will check how it is done by the Turing machine. Okay, so in case of push down automata, what we have done, we have first we take a empty stack and we push all the variables, all a's inside the stack, and while reading the b's, each b's, we go on popping the a's from the stack, and after b is read completely, we have seen that there is no element in the stack. Okay, so that was the concept using push down automata. Okay, but in case of a Turing machine, let us do this in another approach. So I take one tape. As you know, there is infinite length of tape, and let us take it 3a and 3b. So let us take like this way, a. Okay, let us write like this way, a and b, and these are the blank symbols. Previously I told you that either I can write like this way or capital B. So these are the blank symbols in infinite thing. Okay, so these are the A's, 3A and 3B we have taken. Okay, now what is the concept that in case of Turing machine, we will first read one A, and then we will go and read one B. Again we will read an A, and again we will read B. Again we will read one A, and again we will read B. Okay, so and after reading A, we will replace this A by X. After reading B, let us say we will replace this B by Y. And if all reading is completed, both A and B, then we will see that there is nothing left for A and nothing left for B. Okay, so we will do this with the help of the Turing machine. Okay, so let us start with, suppose I am at Q0 state. Fine, and from the Q0 state, so currently my read rate header position is at A position. Currently it is pointing towards A. Okay, so what I will do, I will read A, I will replace this A by X. Okay, and I will move towards right. So I am writing like this way, I will read A, I will replace this A by X and moves towards right. So replace this A by X. Okay, and header will come over here now. Okay, and I will change my state from Q0 to Q1. Fine. Next, what I will do now, that I will keep on reading this A and will do nothing, just I will keep reading A and replace. Okay, and you can say that I will read A and replace A by A, again replace A by A and replace A by A till first B is encountered. So how should I write this way? So let us draw one self loop. So I will read A, replace A by A and moves towards right. I will read A, replace A by A and moves towards right. Again read A, replace A by A and moves towards right. Okay, now after that, what I will do, after that, first B I am ready. So after that I will read the first B. Okay, and I will replace this B by Y. Okay, so I will replace B by Y, small b by Y, and I will move towards left. Okay, I will move towards left, and I will go to another state, that is Q2. Fine. Okay. So now in Q2, when I am in Q2, what I will do, so from I will replace this b by y, and I will replace this means what? Replace b by y and move to left. Replace b by y and move to left. So currently my header is pointing towards, read write position is pointing towards A. I am in Q2 state. Now what I will do? Should I do anything with this? No. I will move till I encountered with X. Okay. So I have to move leftward. So just you go on reading A and replace A by A and moves towards left. So this will be denoted like this way. You keep on reading A, replace A by A and moves towards left. So from here I will go here, and from here I will go here. So just when I reached from this particular, I will read X. So I will remember, oh, this is that X which I have already replaced while reading the first A. Okay. So what I will do now, so I will just read A. So from Q0, let us write like this way. From Q0, I will go to again Q1. So from here, when I reach this one, so this will be, I am reading currently X, and I replace X with X, and again my pointer will start for fighting a new fight with A. So while after reading X, I will replace this X by X, and my header will be go to the right and start the new journey, same journey. Okay. Then same thing will be happened. It will replace this A by X. So A by X moves towards right. Then it read A. Okay. So it read A and replace A by A, and then it read first what? Y. So when it will read first Y, it will do what? It will do nothing. Okay. So you are now at Q1. You have read the first Y. Just replace Y with Y and move towards right. Okay. Then moves towards right. Then your pointer is over here. So you are in Q1 state. You are reading B. Replace this B by Y. Replace this B by Y. Okay. And moves towards left. So when you are moves towards left, so you will again read another Y. Okay. So when you move towards left, you are reading Y. So again this condition will, you are reading Y, you have to do nothing. You replace Y with Y and moves towards left. Then you encountered with A, you have to do nothing. Read A, replace A with A and move towards left. So move towards the left. Then you read X, you replace X with X, moves towards right. So you replace replace this X by X and moves towards right. So again you are in here also. Okay. So after that you are again at Q0 position and do the same procedure. Okay. So again replace this. Again same procedure will happen because already machine had learned many things, and you replace this X by X, this one. Next after this it will go read all the Y. So Y and it will go towards the right, and it will encounter with the last B. So it will replace with B with Y and moves towards the left. So it will read Y, replace Y with Y and left, and after that it will see that there is an X. So it will go over here and again it will move towards the right. Okay. So reading this last X, it will replace this X with X and moves towards right. So then you are in the Q0 state, but you now have encountered a new input, that is Y. Okay. So we have to, in that case, what we have to do, we have to do another thing. So we are reading this y. So first read y, okay, replace this y with y and move towards right, okay, and you are in the Q3 state now, okay. So you are here now. Now again you have to read, again you are reading this, you are reading y, replace this y with y and moves towards right. Again you are reading this, replace this y with y, moves towards right, okay, and you have reached here. So it is a blank. So you are basically reading a blank, replace this blank with blank, and you remove towards the right. And let us say, since you are reading the blank, you are in the final state, so I represent this as QF. So this is the your diagram of this language acceptor using Turing machine, okay. So this is one diagram, and now we can use the ID instantaneous description of this diagram like this way. So I will not do the entire thing, but I will show you a few instantaneous diagram. Let us consider this one. So you are at Q0 state, okay, and your input is A. So you will, from here wherever you are going, you are going to Q1 state, okay, and replace A with X and you move towards right. So this can happen over here. Now for if you want to do this one, so for you can do with this Q1 with A, Q1 with A, so Q1 with A. So again you go to the Q1 state, replace A with A and towards right. Or there is another condition, Q1 Y. So you can go to, from Q1 Y, you are basically replacing Y with Y and you are moving towards the right. Now for this one, you can write this way, you are at Q1, now your input is B. So what you are doing, you have gone from Q1 to Q2 state, replacing this B with Y and moves towards the left. So in this way you can draw each and every instantaneous description or ID, okay. So I'm just writing this too. Okay, there is another thing for this you can write. So for Q0 A it is there, but there is another thing for Q0 for Y. So just I'm writing this, I'm finishing this term. So it is Q0, you are reading Y. So you are going to the Q3 state, replace Y with Y and move towards right, okay. So this is these two things I have done, and you are suggested to do the instantaneous description of this one, this one, okay. It's easy. Now let us draw the table by seeing the same thing. This is what I am representing. This is same as this one. Now if I go for the table description, let us construct the table. So inputs are A, B, capital X, Y and blank, and states are Q0, Q1, Q2, Q3, Q2, Q3 and QF. So Q0 on A, so Q0 on A I can write like this way, Q1 XR. Q0 on B, is there any transition? No, there is no transition, so I will represent it as H, halt, okay. So this is also X will be halt. Let us take this Q2 on X. So Q2 on X, Q2 on X. So Q2 on X will be like this way, Q0, Q2 on X will be, you are going to the Q0 state, replace X with X and this is R, that is we are going to the right. So in this way you can fill up this entire table. So this is an example of language acceptor by Turing machine, and this is the working procedure of Turing machine. It is not the same as the push down automata. Hope you understand this. So in the next example we will go for a to the power n, b to the power n, and c to the power n. Okay, so you better try it, but I will solve it. Okay, thank you now.